Hi guys, welcome back to my channel. Today I'm going to start a new topic, titration, and I will teach you what is meant by the term titration and how can we crack the titration question in my this video. Let's start about titration. Yeah, this is a physical technique. By using this technique, we can find out the concentration of the unknown substances. For that titration, because this is a physical technique, we have to perform a practical. So the apparatus that needs to perform the titrations are, first of all, have you done any titration in your school, guys? So we need a burette, which looks like this. Look at that. This is the burette. I'm not the artist. I'm trying to draw the burette. This is the burette. This is your burette. And we can fill that burette by using some funnel. You have to keep the funnel like this. Burette normally measure 50 centimeter cube. Yeah, and burette, look, this is the burette. Burette always clamp. Look, we have to clamp the burette with the help of some these are called clamping bars, and this is the stand. That's the stand. You have to clamp the burette. Okay, and we also need some conical floss. This is a conical floss. The volume of the conical floss is 250 mil or centimeter cube, same thing. You have a small beaker, 150 mil or centimeter cube. You will provide it by one more small beaker to carry out the chemicals. One more beaker, 150 mil. So that's the stand, and we have to clamp with the clamp bars. Like, look at that in that picture. You have to clamp it. And we need a pipette. It looks like this. Pipette has marking, and the volume of the pipette is also important. You have different types of pipette, but we can use the 50 centimeter cube pipette. There's a marking. I'm sorry, I don't like this pipette. I will draw one more. Nice. Look at the pipette. This is the pipette. And pipette has a pipette filler. It will be with the bulb one or the roller one. That's the pipette. You can fix the bulb. There's a marking. We have different types of the pipettes. We have 10 centimeter cube of the pipette. We normally use the 20 or 25 centimeter cube. How we know that it's a 25 centimeter cube? There's a mark on the glassware. So we need a pipette filler, 2 beakers, and a conical flask and a burette. Sometime you have to make a standard solution. To make a standard solution, you have to weigh your salt. How can we weigh the salt? You have to take the little amount of the salt in that boat-like structure that's called weighing boat. So this is the balance. That's the weighing balance. And you have all these tare value, put it on the 0, 0, put that weighing board on it. That's the your weighing board, put it on that. And you can weigh any like 2.3 gram of any salt. You put it to a T, press the T. When you press the T, you'll get 0.00. Now you can start your reading. Okay. Once you weigh a 2.3 gram of any salt, you just transfer that salt into a small beaker. That's your small beaker, guys. Transfer that salt into a small beaker. Any salt, like you can use sodium carbonate or sodium hydrogen carbonate, anything. Yeah, to make a stand solution. Add a little amount of water. Add a little amount of water. So this is the small beaker. Add a little amount of water and the salt, 2.3 grams. So you dissolve all these salt into the distilled water or deionized water. Then how can we make a standard solution? That you have to transfer into one more very important apparatus. I'm drawing. Can you name that one? I want to rub this one. Can you name this one more apparatus? This is how it looks. Look at that. So there is a marking, and the volume of this apparatus is 250. This is nothing but volumetric flask to make the standard solution. First of all, you have to make your own standard solution, and that standard solution we can use to titrate unknown concentration of another solution. So transfer that one, all your liquid, with the help of the funnel. Add the deionized water up to the mark. And always, guys, make sure whenever you are adding deionized water, you check the lower meniscus. This is called the lower meniscus, guys. So suppose this is the marking. That's your volumetric cylinder. This is the marking. You have to fill like this, not on the top side. With the help of your eye contact, check is that on the lower curve end, not on the upper curve end. So this is my volumetric flask. I make a standard solution with the help of the volumetric flask. Now my solution is ready to do the titration with the unknown solution. So now you have an idea. What's the purpose of the titration? Titration is a technique used to find out the concentration of the unknown substances. So titration mainly deals with two solutions. Sometimes a salt is provided and you have to make one solution. So this is a technique where we deal with two different solutions. So there are two different types of titration. One titration is the acid-base titration, and another titration is the redox titration. First, we will start the acid-base titration. Then I will teach you the redox titration. To do the redox titration question, I have to teach you how to balance the equation, what is a redox reaction. Then we can do the redox titration, acid-base titration and redox titration. So titration normally contain two solutions. So suppose we are doing today I'm going to teach you how to solve the question based on titration. And today we are doing only acid-base titration. So two solutions definitely will be provided to you. One is the acid, and another one is the base. Or the acid form a salt or base form a salt. So I didn't get you. Okay, no worries, guys. I will come to that point. So two types of titration: acid-base titration. Look at that. Before that. So when the acids, we have to focus on acid-base now. Then we will do the redox titration later on. Look at that. When acid, any acid or acids, when react with the base or alkaline solution, bases, they react to form, any idea, guys? Acid, and when combined with the base, we will get salt plus water. And this process is called neutralization. So titration is the technique in which we neutralize the strength of the acid with the help of the base, or the strength of the base with the help of the acid. One more thing, can we use, instead of bases, can we use alkaline solution? Yes, acids plus alkaline solution. What is the difference between a base and an alkaline solution? Any idea? So base is a chemical substance which can accept a proton. Then what's the alkaline solution? Write down the definition of a base. Base is a chemical substance that which can accept a proton, H plus ion or a proton. Now, what is an alkaline solution? Alkaline solution is a chemical substance which contain OH minus ion, hydroxide ion. And when you dissolve alkaline solution in water, it gives away OH minus ion. So all the alkaline solution are bases, but all the bases are not the alkaline solution. I will give you the example. Look at that. Don't worry, you have a separate topic of acid and bases. I will teach you what is the definition of acid and a base in terms of Laurian-Bronsted or Lewis constant. Now, so ammonia is a base, is not the alkaline solution. Alkaline solution, what are the alkaline solution? First of all the alkaline solution contains hydroxide ion, OH minus ion. And when you dissolve that OH minus ion, it will give away OH minus ion in water. Okay. Let's see the examples of alkaline substances or alkaline solution. All the group 1 and group 2 metal hydroxides are alkaline solution. Group 1 metals: lithium, sodium, potassium, rubidium, cesium, francium. I'm not using the francium. Francium is the radioactive element. Lead, beryllium, magnesium, calcium, strontium, barium, radon. I'm not using the radon which is a radioactive element. Okay. All these group 1 and group 2 metal hydroxide. You know the formula of the metal hydroxide? OH minus. Okay. I will teach you guys about the positive ion, negative ion, ionic bond. But anyway, group 1 metals, they can give away one electron. They lost one electron, so they have a positive charge. Group 2 metal can give away 2 electron or lost 2 electron, so they got a +2 charge. Now, can we write the formula of group 1 metal hydroxide and a group 2 metal hydroxide? Yes, we can write. For example, what is the chemical formula of the sodium hydroxide? Easy. Sodium hydroxide, sodium hydroxide, which is a base as well as an alkaline solution. Sodium, which is from group 1, and it can give away one electron, so it has one positive charge. Hydroxide, OH minus, 1 minus. So put 1 to this side and 1 to this side. This technique is called crisscross method or simply cancel +1 and -1. So you're getting sodium hydroxide, NaOH. Agree? Now, I will show you what will be the chemical formula of group 2 metal hydroxide. What is the chemical formula of calcium hydroxide? So we know that calcium is from group 2 and calcium will lose 2 electrons easily because it has 2 extra electrons in the outer shell. Okay, Ca2 plus lost 2 electrons. We know hydroxide, OH1 minus. Look at that. So I showed you crisscross technique. Only take 1 and times 1 with the calcium times 2 with OH, not the charges, just the number. So CaOH2. Is that right? No, it's not right, guys. This 2 should be multiply or times with oxygen and hydrogen. Whenever we have a unit, whenever we have more than one element, more than one atom, you have to put bracket and times by 2. So that is the chemical formula of calcium hydroxide. Okay, now we will see some chemical formula of acids, and we will combine some base and acid to get salt plus water. That's the actual technique to figure out the concentration of the unknown substances. Unknown substance can be acid or alkaline solution by using titration technique. Okay, acid is a chemical substance which can donate which can donate H plus ion or proton. Now, we will write some formula of the acid and what salt it can form when it combined with alkaline solution. Look at that. These are the common acids which we normally use in titration. Can you name the first one? So these are the acids. Name of the acid. Any idea? Yeah, I'm coming. Just I want to rub this part. Guys, listen. These tabular form which I'm doing now is very important. You can use this for your first year A-level chemistry and your second year A-level chemistry. You can't see this type of notes in any textbook. Now, acid form, acid gives away H plus ion. What's the name of the acid? Name of the acid, name hydrochloric acid. Now, nitric acid, or some teacher, nitric acid or nitric acid. NiTric acid. Third one, phosphoric acid. Phosphoric. Sulfuric. Carbonic, all acid. Carbonic. Last one, ethanoic. The common name of arsenic acid is acetic acid. Okay. And we know that acid is a chemical substance which gives away a proton. Look at the overall charge. No charge on HCl. If it gives away H plus ion, what ion left? Cl ion or ions. We will left with Cl minus 1 minus HNO3. It gives away H plus. So you have NO3 1 minus. That's the overall 1 minus. This is overall charge. 1 minus PO4 3 minus, because it gives away 3 proton. PO4 3 minus. It's a tribasic acid. I will teach you what's the meaning of tribasic. Sulfuric acid, it gives away 2 proton. So SO4 2 minus. Carbonic CO3 2 minus, and CH3 H3 COO 1 minus. You know, guys, any non-metal with a negative charge ends as ide. So suffix is id. Non-metals, these small tips, they're useful when you are writing your examination. Non-metals with negative charge ends as, or with the suffix as IDE, like chloride, oxide, sulfide. So what's the name of the ion? Name of the ion. Name of ions. Name of this ion, chloride. What's O2 minus, oxide? Now look at that one. All these acids, phosphoric acid, sulfuric, carbonic, ethanoic, all these acid guys ends with ic. So look at that one. Ic acid, ic acids, all the ic acid with the inverted comma form ATE salt or ATE ion. So I didn't get it. Okay, no worries. So whenever you make a salt with this type of the acid, you name the salt ending with 8, because ic acid always form 8 salt. Like nitric, it form nitrate or nitrate. TRATE. Like eat 8. It's end with 8. Phosphoric, phosphate. So I will teach you how to write the formula of sodium phosphate. Phosphate. Ic acid always form 8 salt. And the acid which has more oxygen is more powerful acid. So these are the strong acids which we used in our chemical lab. Phosphoric acid form phosphate salt. Sulfuric, sulfate. FATE. Please make a note. Take a picture of this if you can't make a note. Carbonic, carbonic. Last one, sorry, carbonic form, carbonate, sodium carbonate. I will teach you how to write the formula of sodium carbonate. Most of the student, even though they are doing A level, but they struggle to write the chemical formula and balance formula. So carbonic form, carbonate, 8 salt, and ethanoate. Yeah. Does this make sense? Look at that. Ic acid always form 8 salt. Okay. So some student asked me, sir, this is a nitric acid or nitric acid. So what is this one then? HNO3 NO2. Any idea? This is called nitrous acid. And we can name it by using its oxidation state. When I will teach you the redox reaction, I will teach you how to name it. Okay, so look at that one. We have us acid and ic acid. Like all these acids, they have nitrous, phosphorus, sulfuric acid with one oxygen atom less. So one more thing, like ic acid always form 8 salt. And look at that. Ic acid always form 8 salt. No, us acid, nitrous, TROUS, us acid. Us acids form ite ion, ITE, nitrite, nitrate. See, nitrite and nitrate. Sorry guys, I don't have enough space. But anyway, look at the one more thing before I conclude everything. Look at that. NO3, 1 minus is nitrate. NO2, 1 minus is nitrite. This is nitrite. It ends with ite. Nitrate, it ends with 8. Then one more thing. Is that okay? Yeah. Look at that. So this is, can you name it? Can you name N3 minus, NO2 1 minus, NO3 1 minus. In the same way we have all this. Can you name these 3 ions? They look very similar. Most of the students are getting confused with N3 minus, NO2 1 minus, and I have decided I have to make one video particularly on this to differentiate. So this is IDE, nitride, IDE. I told you, with the negative charge and with IDE. TRIDE, IDE, nitride. And look, NO2 1 minus, this is nitrite, ITE, NITRITE. And this is nitrate or nitrate, 8 salt. This is 8, this is ide, this is ide. Same thing for phosphorus, phosphite, phosphate, phosphide. Okay. See, today we have learned the definition of the titration, what's the purpose of the titration, and we have seen some picture of the apparatus that we commonly use during the titration. And one more thing, when you do the titration in your lab, you have to add the indicator before you start the titration. I will teach you what is the purpose of titration in my separate video. So guys, and today we have learned the definition of the acid, what is meant by the term acid, what is meant by the term base, and we have seen how to write the chemical formula of the acid and the bases. So I think I want to stop the video here. In my next video, I will teach you how to solve the titration question. Sometimes they will ask to find the concentration of the unknown solution in terms of mole per dm cube or in terms of gram per dm cube. And we have to use the same titration technique to figure out the percentage purity of the chemical substances. Okay guys, thanks for watching this video. Thank you very much.